Okay, two problems. We have an inequality. Use your A and B numbers. Solve this inequality. If you can't solve the inequality, then make that an equal sign and solve. Okay. The inequality is a little tougher than the equality. If you solve the equality, that's good. You solve the inequality, that's real good. Okay. And then we have a graph here. Now, your A, B numbers, I'm probably going to give you a point that looks like, yeah, I could. But anyhow, you have A and B numbers here. That's where the point of this thing is, the vertex. And the slope on this side is -2, and the slope on this side is 2. Find the equation of the graph. It's an absolute value function. It's a transformed absolute value function. See what you can do with it. And now, everybody seems to be pretty well prepared here. You know, you learned some stuff. People did pretty well on the assignment, quite well. Okay, so what's more, I'm favorably impressed with what you all are doing. So let's walk. Okay, so taking this inequality, let's say we've got absolute value of x minus 2 greater than or equal to 9. Now, actually, I'd like to start with the question about what this tells us on the number line. This is the distance between x and 2. Okay. So on the number line, this is telling us that 2 is here, and x, the distance between x and 2 is at least 9. Well, that means go 9 units this way. We're at 11. If we go 9 units this way, we're at -7. So between here and here, the distance between x and 2 is less than 9 if we don't include the endpoints. Okay. If we want the distance between x and 2 to be greater than 9, that's going to occur here. Here. So we just used a little bit of simple geometry to essentially solve the equation without doing any algebra. Now, sometimes we've got to do algebra. Okay. In this case, if we just have a 1 in front of the x, we can just reason it out. Now, the reason I want to do that is, number one, that's handy if you've got an equation like this. But if you had a 2 in front of x or something like that, it would work. So we can say that the solution is the interval from -infinity to -7, including -7, union the interval from 11 to infinity. Now, algebraically, Absolute value of aardvark greater than or equal to B. It's true if aardvark is greater than or equal to B, but it's also true if also true if their aardvark is less than negative B. Okay. So for example, if B is 9, in this case, okay, whatever this is, just call it your aardvark. And if your aardvark is greater than or equal to 9, this is going to be true. If the aardvark is less than or equal to negative 9, like negative 10, it would still be true. Because negative 10 has an absolute value of 10, and the absolute value of 10, the absolute value of negative 10 is 10, and that is greater than or equal to negative 9. One way to see this is if X is a really big positive number, or if aardvark is a really big positive number, it's got to be true. A really big positive number is going to give you a big positive value of the absolute value, obviously. If it's a really big negative number, like negative 7 billion, the absolute value is still 7 billion, which most people believe is greater than or equal to 9. Okay? Makes sense? So I'm going to say that because the whole idea of what happens for really big positive and negative numbers could be really important in your homework for next time. We want to start considering what happens if a quantity is a really big positive number or a really big negative number. You'll see how that works in a short time. If aardvark is a huge positive number, absolute value of aardvark is a huge positive. I'm saying then if aardvark is a huge negative number, its absolute value is still a huge positive number. Its absolute value is still huge, but it's positive. Okay. And that's consistent with this picture. Well, algebraically, we have this. Algebraically, then, not a lot of room. That should be obvious, but that's a translation of the solution we just saw here. X is greater or equal to 9. X minus 2 greater or equal to 9. Or x minus 2 less than or equal to negative 9. X minus 2 being the distance between x and 2. So that this has an easy solution. We add 2 to both sides. There we have it. And again, same as solution we see that. Okay. There's your rule. Now, if you have like absolute value 2x minus 2 greater than or equal to 9, a little harder to translate that directly to a picture. You want to do it algebraically. Let's make it 4x minus 2. This translates to 4x minus 2 less than or equal to negative 9. Or 4x minus 2 greater than or equal to 9. Just mindlessly the same thing, because whatever your aardvark is, it translates like this. And let's see if I can got all that. There we go. Okay. This is easy to solve. We add 2 to both sides, we get negative 7, we divide by 4. Here we get x equals negative 7/4. And it's not equal, it's less than or equal. Or x is greater than or equal to 11/4. Okay. Well, there's more I can say about this. We've got other things to do. There's common caution that I believe Open Math has done a good job of cautioning you against, and you probably already knew it. When you're solving an inequality, if you divide or multiply by a negative, it reverses the inequality. Everybody familiar with that one? Let's just do one, just to be sure. Let's just take a simple single inequality. Right. Let's make that a negative 5x minus 12. So that's okay. We can always add or subtract the same thing on both sides, like we do with an inequality. We get negative 5x is less than 32. And 12 on both sides, we get this. Then we want to do negative 5x over negative 5. And you might want to write down less than 32 over negative 5. That's our habit. Now that doesn't work. As soon as we divide by a negative, the less than becomes a greater than. And if it's greater than, it will become less than. You switch the direction of the inequality. So that we get x greater than negative 32. And of course, we check. 32/5 is a little more than 6. Not a little more than, okay. 32/5 is a little more than 6, and negative 32/6 would be a little less than negative 6, right? Well, what's a number that's greater than negative 6? Quite close, negative 5. Okay. Put in negative 5 here, we get negative 5 times negative 5, which is 25, right? And 25 minus 20, or minus 12, is 13. Less than 20, right? If that was negative 6, if that was negative 6, that's still bigger than negative 6 2/5. which is what this is. We have negative 30 minus, we have 30 minus 12, which is 18. We're getting close to 20. If we go to negative 6 and 2/5, well, negative 5 times negative 32/5 is negative 32. It is 32. 32 minus 12 is 20. And that number is where these two quantities are equal. Okay. You can't have that number because it says less than. 20 is not less than 20. But any number greater than this negative 6 and 2/5, this negative 32/5 is going to give you something less than 20, because the bigger this number gets, bigger the negative you're adding to them. Well, nobody works there. Okay. There it is. So you got to remember to switch to the inequality when you multiply or divide by negative. Okay. So let's look at this graph. You're all doing quite well with the whole idea of translations. Let's say that the graph goes through, has a vertex at 8, 5. You wouldn't get those numbers from your A and B's because your B is always bigger than your A, but it's still a valid problem. Okay. And the slopes are 2. And negative 2. Actually, this is a slope of negative 2, and that's a slope of 2. I think I wrote it wrong. Yeah. That slope is 2, that slope is negative. Still. What do you know? We took basic absolute value function. We turned it upside down. And then we shifted it 8 units to the right and 5 units up. Okay, well, everybody pretty much got that. Okay, so you said, okay, let's talk. Y equals absolute value of x minus 8 plus 5. That would translate it 8 units in the x direction and 5 units in the y direction. I think everybody was good with that. I didn't really check carefully your signs here, but I think that's what just about everybody did. Okay, well, that's good, but that's not going to give you a slope of 2 here and negative 2 here. And what's the slope of negative 2 mean? It means every unit you go over, you go down 2, right? Or more appropriately, whatever you go down 2, you go over 1. Okay. How many times do you have to go down 2 to get from this point to the x-axis? 4 times, right? So you go down 2 and over 1, that puts you at 6, 6, right? You're going to go down 2, that gives you 8 minus 2, that's going to give you 5 plus 1, which is 6. Then you're going to get 4, 7, 2, 8. Okay, 0, 9. So you have the 0.09 here. So the 0.09 doesn't work because if x is 0, I don't know why I do that. So if this has a slope of negative 2, one way or another, you can find another point on the graph. I chose to just find the x-intercept because it's usually important to know the x-intercept. That's all. If you plug x equals 9 in here, you get 9 minus 8, which is 1, added to 5, which gives you 6. So what's wrong with that? Well, one thing that's wrong with it is you have to have a negative in front of here because this thing has been flipped over. Okay. So if we try to fix it by putting a negative in here, we get a little better. 9 minus 8 is 1. That's the value is 1. Negative 1 plus 5 gives us 4, but it doesn't give us 0. Okay. Well, at this stage, not quite right, because you should understand that you could check the result. See if it makes sense. Okay. You could even estimate what your x-intercept is and see that no, that's not going to make any sense. It's on the wrong way. So formally, you could say, okay, gotta have some number out front here. That still has a vertex at A5. They're still in good shape. If you get a second point on the graph like 9, 0, you get 0 because A times absolute value 9 minus 8 equals 5. And you see, derivative of A times 1 plus 5. And it's all that you get A equals negative 4. That makes sense. So you've done that with scoring functions and stuff like that. You use your general parameter, your multiplier here, your vertical stretch or reflection or whatever. Okay. Because this tells you you're vertically stretched, compressed, and are you flipped across the x-axis, right? It's greater than 1, vertically stretched. It's less than 1, you're vertically compressed. It's negative, well, kind of the same thing, except you flip across the x-axis. So A equals negative 4. So now the equation is y equals negative 4 times the absolute value of x minus 8 plus 5. And most people didn't write anything in front of here. Some people wrote it like a negative 1, which is good progress. You recognize it's upside down. Okay. Still not sure how to find the number. This is one way. OpenML is telling you some other ways. So you might want to go back and look at problems like this, because this is proving to be a little bit more challenging than a lot of other things when you're given a graph and asked to figure out what the function is. You know, it's obviously a parabola, it's obviously an absolute value, obviously a cube, obviously reciprocal or reciprocal square. Okay. But from there, as I say, it's a little bit challenging. I don't think that was all on the screen. Yeah, I think it was. But there's some writing behind it. Well, okay. Well, that's all we're going to say for right now on the absolute values, because as I say, people did well on the homework. But make sure that you're picking up all the principles and understanding it deeply enough that you'll have it when you need it. Okay, now when we were over here doing a little extra reasoning on inequalities, we considered what happens if what's inside the inequality is a huge positive number or a huge negative number. Okay. I said that was going to be important, and then here we go. Okay. Let's start with an obvious one. Let's let y equal x cubed. Okay, so I'm asking a question. If x is a huge positive number, what can you say about y? Okay, so the answer, good answer was, yeah, y is going to be a huge number. Okay, and it's going to be a huge positive number, right? And as I said, if you got a huge number and you square it, well, you got that many of the huge number. Okay, so just imagine you take a handful of sand and spread it out in one of these tables and count them, right? There are a lot of, probably, in the millions grains of sand if you take a good handful. Okay, it's fine sand. And then whatever number you counted, you go scoop that many handfuls out. Okay. Now, you count to 1,000 in about 20 minutes. You count to 3,000 in an hour. Okay. Next 24 hours in a day. So you count about 72,000 in a day if you count it for 24 hours. Is that a million? I'm just going to have to do that about 14 more times. It takes about 14 days at 24 hours a day. If you just spend half your day, it takes you about a month. Count to a million. Okay. Take a while to count those grains of sand. Then you got a huge pile of sand, and you start scooping out handfuls, one every second. Okay. Takes you a month. You're gonna have a pretty good sized pile of sand. How many grains of sand? It's gonna be a huge number. Okay. It's gonna be like a million times a million. Okay. But you're gonna cube this thing. So you got to go back and do all that again a million times. It could take a lifetime. So a million is not even that big a number. Numbers, our federal budget's in the trillions, so you're going to have to do a million lifetimes to get a trillion grains of sand that way. We got a big old steam shuttle or whatever, if you get a little quicker. It's a lot of sand. Okay. Just trying to get a handle on how big numbers can get, because that's kind of important to see about. Okay. Now, what if x is a huge negative number? Think about what you would have if y was a huge negative number. Okay, how would you describe what y will be if x is a huge negative number? I'm going to say y will be equally super humongous number, but it's going to be negative, right? negative of a superhumongous number. Okay, well, we can't keep writing out superhumongous. And we kind of lose how humongous these things get by writing it this way, but we say as x approaches infinity, we know that y approaches infinity, okay? And here, okay, x approaches negative infinity, y approaches negative infinity. We could say something about faster and faster. We kind of want to think that because we're going to get a feel for how these things approach infinity. But we can see this in the graph. The graph of basic Cuban function looks something like this. Okay. So as x goes to infinity, that means as we move to the right, so x goes infinity, y goes to infinity. Now I kind of don't draw two arrows for that, but I just drew this arrow to indicate x keeps going this way, y is going to go this way. And because of the way multiplication works, in this case, thing goes to infinity real fast. Okay. As x goes to negative infinity, y goes to negative infinity. Okay, no big surprise there. Now, I'm not going to write it out. We're going to discuss it for a minute. The question is, what happens to the y equals x squared function? So we will write it out, but without the reasoning. The question, what happens to y if x goes to infinity and y goes to, and if x goes to negative infinity? Okay, I got good answers here. If x goes to infinity, as I said, that means x becomes an unlimitedly humongous number, okay? Or an unlimitedly huge number, which means y becomes unlimitedly humongous because you're squaring big number. As I've said before, that's, you know, handful of sand and then that many handfuls of sand, okay? Take a month just to count the handfuls, and another month if you can do one handful every second for half a day. You know, it was sore arm. Okay. So you want to understand why the y goes to infinity, and here y still goes to infinity because you're squaring a negative number. So you square a huge negative number, you get a humongous positive number, unlike when you cube a huge negative number. Okay, so now you understand everything about polynomials, right? No, but you understand one of the important characteristics of polynomials. Okay, so question now. Instead of what happens to y if x goes infinity, I'll just say what are the limits as x goes to infinity and x goes to negative infinity? What are the limits of this expression? So I turn the recording off for a minute, we'll discuss it. Actually, before we discuss it, one answer is obvious. As x goes to infinity, this goes to infinity, and this goes to infinity, right? So in this case, y will go to infinity. Now, x goes to negative infinity, takes a little more thought. Okay, so yeah, the thing you have to think about is this is going to be negative, this is going to be positive, right? Well, the negative, well, x cubed is a lot bigger than x squared. Okay, handful of sand, that many handfuls of sand, no pile of sand, million handfuls of sand. Okay, you know, a handful of sand's about a pound, so you got about 500 tons of sand. And with a shovel, you can load a ton of sand in about 20 minutes. With a hand, it takes a little longer. But again, that's way more sand than that is. Okay, and if it's a negative number, it's a huger negative number than this. Notice I didn't really say it because okay, x squared gets humongous, but x cubed gets super humongous, big numbers. Okay. And I'll just make a note here. Cube of a large number is greater than a square. Okay. Okay, well, that's all fairly straightforward. This is fun, so let's have a little more fun. What about 1000x cubed plus x squared? Okay, now I'm not sure whether I corrected what I wrote before after I took the camera off. We wouldn't look at x cubed plus 1000x squared because 1000x cubed plus x squared is pretty obvious. In this case, it's not obvious. Okay, so somebody said if x is big enough, then this will still be bigger than this. Okay. Yeah. How big does x have to be? Somebody suggests, well, maybe x is 100, maybe if x is 100, this will be bigger. This will be bigger than this. Okay, if x is 1, this is a whole lot bigger than this, obviously. 1,000 is bigger than 1. If x is 100, x cubed, 100 cubed is going to be 1 followed by 6 zeros, right? And if you don't understand that intuitive idea, you really maybe need to review basic arithmetic. But anyhow, it is. You can write it out. 1,000 times x squared, if x is 100. Well, 100 squared is 1 followed by 4 zeros. That's 10,000. Okay. And 1,000 times that adds 3 more zeros. You got 7 zeros in this one. You've only got 6 zeros in this one. So you don't have enough zeros yet. But if you go to x equals 1,000, think about it. If x is 1,000, these two numbers would be equal, wouldn't they? Because 1,000 times 1,000 squared is just 1,000 cubed. Okay. And if x is bigger than 1,000, then this is going to be bigger than this. Okay. So let's read it out. Yep. In this case, x cubed would be greater than 1,000x squared. As x goes infinity, y goes to infinity, obviously, but the kicker, and this is what happens as x goes to negative infinity. Y goes to negative infinity because eventually x cubed dominates. Okay. Okay. In a polynomial, okay, if this is a polynomial, it's a combination of power functions. What do you think happens as x approaches negative infinity? Okay, for a general polynomial like this, the highest power dominates. Highest power here is a fifth power. That's called the degree of the function. You're going to see that terminology in open math, so I'm not going to write it down for. So the question is, what happens to the highest power as x goes to negative infinity? I want to start with negative infinity because it takes usually a little more thought than infinity, but infinity would still be a question. Okay, as x goes to negative infinity, what's going to happen to the value of y? Okay, so x to the fifth because the obvious thing, the high power of negative is negative. The high power of, yeah, okay, just like we saw it for x cubed. Negative times a negative gives you a positive, but then times a negative, you get a negative. Well, here you got negative times negative is positive, times a negative is negative, times a negative is positive, times a negative is negative. You don't have to say that every time. You can generalize and see that there's a pattern here. Even powers are always positive. High powers of negatives are negative, okay? Okay, so we have this, okay? Now, x and fifth dominates all over powers, so X goes to negative infinity, Y goes to negative infinity, right? Now, let's just say I've got a bunch of negatives in here instead of positives, with some kind of big coefficients in front of them. Well, X of the fifth still dominates those the same way X cubed dominates 1000X squared. X of the fifth is really going to dominate these guys because they're much lower powers. Okay. I'll just make a more abbreviated statement. You see more about it when you do the homework. Good enough? Okay. Well, that's an important characteristic of polynomials, and you'll see other characteristics when you get into the homework. But if you understand this, it's probably the hardest thing to understand in the upcoming section. So you'll be in good shape. Okay. Anyhow. Okay. This is a quadratic equation. It's a polynomial with powers of X and coefficients and stuff like that, okay? Solution to this is given by this formula. Now, how many of you seen that formula before? Okay, everybody should have seen that formula. If you've had the pre-regular course, if you had an Algebra 2 course, you've seen it. You might not remember it. You know, I've said this before just an hour ago. I went to a very selective science and technology school, just chemistry, physics, mathematics, engineering, and so forth. No biology, no geology, just the hard sciences, okay? I was put into a calculus class where everybody's pretty much in the top 1 or 2% of their high school class. I remembered the quadratic formula, but more than half the class didn't. So if you don't remember the quadratic formula, you've got a lot of good company because they were really smart people, okay? And then, you know, I wasn't as far from the smartest person in the class because when you get to school like that, you realize that some people are like decent high school athletes and some people are like professional football players, okay? You look at somebody who's a lot better than you think, yeah, I guess they're about the same as professional football player. No, okay, there's no comparison. Okay, so, you know, I was a pretty smart guy in with a group that had at least a few super smart people. Okay, but in a group like that, I think we didn't know the quadratic formula the most. Okay, so this is a quadratic formula. I didn't ask you if you remember what it was called, but that's what it's called. This is like ax squared plus bx plus c equals 0. Okay. So in this case, a would be 1, as number in front of x squared is 1. It's understood to be 1. B is 7, so I can fill in 7 there. At a negative sign in front of it. Now there's more stuff. There's still numbers to be filled in. A is 1, so I can fill in a 1 here. I fill in 1 here. And C is negative 15. And then you simplify this. And you have your solutions for X. Okay. I'll put an f of x there instead of this, like a specific f of x is just a transform square function. Okay. So f of x is a times x minus h quantity squared plus k. H is your horizontal shift. Okay. And that horizontal shift is sitting right here in the quadratic formula. It's negative b over 2a. We'll make sense out of this next time. Okay. A is the coefficient of x squared. Now, if I expand this, I'm just going to get an x squared here, but then that's going to be multiplied by a. So the coefficient of x squared here is a just as it is here. So if you're given something like this, we can immediately see how far we have to shift the function, the graph of our basic squaring function in the x direction. And even before that, how far we've got to stretch it or compress it, and whether we have to flip it over the x-axis, because that's what a tells us, right? Okay. The only thing we don't know is k. Well, k isn't hard to find. If x equals h, then f of x equals k, right? Okay, so here's your vertical shift. Your vertex is at h, okay. Now you should understand that just by what happens when you transform the squaring function. Right? You know, your 0, 0 point is your vertex. If you shift at h units and then k units, then that's where your vertex is going to be. Okay. Whether you stretched it or not at the beginning or flipped it over. Okay. So your vertex is clearly at hk. If we just have this form, not this form, we can write this form. We can write a immediately because it's what's in front of x squared. We could write h, it's negative b over 2a. If we got this form, it's a little harder to get k, but it's pretty easy to do because the coordinates of the vertex are hk. A is just f of h. The value of f when x equals h. In other words, you plug h into this. H in this case would be negative 7/2. Put negative 7/2 in here, we get the y coordinate of our vertex. And so we have now a summary of the graph of any quadratic function. The vertex is at HK. H equals negative B over 2A. And it equals F of H. Because F of H means whatever H is, you plug it in for X. You have X and Y intercepts. And you have an axis of symmetry, which is supposed to have gone right through that vertex. Try again. Okay, here's the line where X equals negative B over 2A. Here is an X-intercept. Because the X-intercept is when Y equals 0. Y equals F of F, which equals 0 when X is one of these two values. Over here is another X-intercept. I wrote that B squared minus 4C pretty small, so they don't have much room. There's the other vertex on equal sides of the axis of symmetry. The axis of symmetry is just where the y-axis goes when you shift the basic squaring function, right? Okay, so that's where, you know, that was the y-axis, but you shifted and stretched and all that stuff. And then you have the y-intercept. Y-intercepts occur when X is 0, as you know from linear functions. It's true of any function. And if X is 0, all you have is that negative 15 there, right? In general, if your function is ax squared plus bx plus c equals 0, there's an entire picture of your graph. And those are things you want to put together. Now, probably going to modify the assignment. I'm going to have the thing assigned for Monday night. We'll leave it assigned, but with the expectation you're probably, a lot of you probably aren't going to get it all. Get as much as you can so you're prepared Monday when we really discuss this, okay? If you come in unprepared, well, you aren't coming in, okay? The class, you're doing just wonderfully on that. Do what you can there. You can spend at least a couple hours in that assignment. And then, of course, you have the assignment of polynomials, okay? Very good. Have a great weekend.